Hello, my name is EthanRansom, and this is my machine learning final project. So my original idea was to create a model that could detect any computer alteration of an image, and I wanted to really go with this idea because of the data set that existed for doing something exactly like this. The Adobe 5K data set. It's an extremely large data set of 30,000 different JPG images. There is the raw data. There's 5,000 variations of photos. There's the raw photo data. And then there's each photo in 5 different variations of computer alterations. So things like 5 different Photoshop artists doing altering it in some way, and then having that to test against the raw data. So it was an extremely good data set and seemed like a great idea, but I learned that pre-processing and working with that data set was extremely difficult. And so unfortunately, after exhausting all my options, I had to go with a plan B. So I decided to go with a binary classification issue, one that has to do with spam emails. The problem we're addressing in the enterprise world is that of spam emails. As a relatively new system administrator, I've been becoming really familiar with Defender 365 quarantine filter. So I wanted to create a model that could analyze a quarantined inbox and predict which emails were spam and which weren't. The success would basically be measured on the accuracy score in a confusion matrix. The high accuracy score indicating a strong model, and in a more readable confusion matrix would display the number of true positives, false positives, true negatives, and false negatives for each class that was being tested. My desired output ideally was to achieve high accuracy on this test set, while also having good precision and recall values for each class. This would indicate the model is able to correctly classify the data and distinguish between the different classes, but unfortunately, with spending so much time into my other idea and having other things going on, I didn't have as much time as I wanted to be able to mess around and tweak and alter things. Continuing on, originally I thought this was to be a binary classification problem due to there being spam and no spam, but later found it is a text classification problem. So I chose to work with the data set I found on Kaggle called the email spam detection data set. It was new, highly usable, and it was a smaller one, and due to my past experiences, I wanted something that I thought would be easier. So for training and evaluating, I trained and evaluated a binary classification model to predict whether a given text message of text is spam or not. I tried to split the data into training and testing sets using the train test split function from the SCI kit-learn library, and I then used count vectorizer function to transform the text into numerical features, and then trained a multinomial naive Bayes model on the training data. So, what I've learned, although my original idea failed and my fallback plan didn't turn out the greatest, I have still learned an impressive amount of knowledge in different machine learning algorithms, data processing and cleaning, various training frameworks, and AWS Data Wrangler. It's a very valuable, powerful tool for helping you process data, and also Jumpstart. I learned much more about S3 buckets and uploading objects to them and this and that, and I learned so much about SageMaker Studio. I'm totally comfortable using it, and all around everything about the machine pipeline was learned. So my model does not meet the business goal The accuracy score it got means that there was issues with the model training. It's predicting all labels as the same value, resulting in its low accuracy. And then the matrix, consisting mostly of zeros, means that there's an issue with my model predicting any class labels. So some of the most challenging things of this were the amount of code involved, as it can get real confusing to me. Also just the general concepts of things like the training algorithms, pre-processing data, evaluating models. Those are all things I consider to be high level and complex. And lastly, the stress of having a somewhat demanding full-time career and also being a student can get to the better of you sometimes, as it did with me in this final project. And then lots of real basic things, working with a lot of the real basic libraries. A lot of this will look familiar with how much it was gone over in all the labs that we did throughout the modules in the semester. So we have there importing the data, importing the pandas library. We have that sklearn, that's the popular open source machine learning library for Python. Its popular one provides consistent interface for various different algorithms. So that's what I tried to do. We just load the data in. It gets combined with the least frequent labels into a new label called the other. I was having an issue originally, getting any kind of output following a guide helped me with that code cell, combining the least frequent labels. Then the data gets split into the training and testing sets. Then the text data into numerical vector representation. And we run that naive Bayes classifier training algorithm. Get some output there. And then having the code to predict the labels on the test data using that NB classifier there. So the naive Bayes classifier was used to train and evaluate the model using the multinomial NB. That's what it was called, and that comes from that sklearn library. And we have some of our results, seeing the low score and low spread of numbers. I do feel like with the things I was able to look up near the end, I feel like I did get lots of good direction at some of the things that were going wrong and what I could have done to alter the data, but like I said, I'm just running out of time and everything going on. So this stuff is definitely cool, definitely something I think I'm going to continue looking into on my free time, as I'm sure it will be able to benefit my career in the future. But other than that, good final project, and thank you everybody. Have a good one.